Okay, it's 9 a.m. So let's get started. Today's tutorial will be reasonably short because there's really just 2 questions. Okay, so let's start with question 3. Ben. Ben, are you there?
Yeah, hi.
Okay, good. Okay, so question 3 says that 2 independent samples of Army and Guards recruits are selected, and the time fixed for each recruit to run 2.4 kilometer in your IPVT test is recorded. Want to know at 5% significance level whether guards or Army recruits have different running time. So what test should you use? So B.
I use Wilcoxon rank sum test.
Yeah, Wilcoxon rank some stats. Okay. Okay. If this is parametric, what test will you use? That means if these two are normally distributed, what test will you use?
Independent t-test.
Independent t-test. Okay. So since actually we don't have to do question part A, but what do you think Shapiro-Wilks test is doing? For this question? What do you think Shapiro-Wilks test is doing?
Not too sure.
Not too sure. Go find out lah.
Okay, sure.
Go and Google what Shapiro-Wilks test is doing.
Test for normality.
Yeah, right. This is Shapiro-Wilks test is actually a normality test. So it's actually to test whether is the sample that you have normally distributed or not. So in this case, guards is normally distributed, Army is not normally distributed. Okay, that's why you cannot use your t-test. Both have to be normally distributed before you can use a t-test. Okay. All right. Then a student actually compute the test statistic. Your T for Army is 55, your T for guards is 36. Which one should you use?
Army, because it has the smaller sample size.
Yeah, so you use this because it's smaller sample size. Okay, given the critical value is 27 and 57, what is the conclusion based on this statistic?
We fail to reject null hypothesis.
Fail to reject null hypothesis. Okay, essentially this is this is almost like your confidence interval. Okay, the critical value for your Wilcoxon rank sum test is almost like a confidence interval. So you have 27 here to 57, but your statistic is actually in here. Okay, then fail to reject null hypothesis. So what's the conclusion? Is there a difference or there's no difference in time?
No difference.
No difference in time. Okay, good. Yep. Okay, so question 4 is also okay. So we go to question 5, and that's the end of it. Then we go to your true false questions. Okay. So any problem with question 3 first? Okay, so question 5, we want to investigate whether adults above 60 years old report verbal presentation verbal presentation of materials more accurate from their left or right ear. Okay, so a test is carried out. Okay, the data is found to be positively skewed, so number of words reported correctly. So when a person is older, as you get older, your left and right ear starts to behave differently. Okay, and that is why for elderly adults, they tend to be more prone to falls because the balancing is off already as well. Okay, so what test will you do? So let's try from the bottom now. Okay, Jianing.
Wilcoxon sign rank test.
Yeah.
Hello.
Yeah, correct. It's Wilcoxon sign rank test.
Because it's the same individual, then you
Okay.
get two readings.
Yeah. So if this is a parametric test, what will you do? That means if they are not normally skewed.
Uh,
What's the T equivalent for it? T-test.
Dependent
PET
t-test.
T-test. Okay, also known as a PET T-test. So what is the null and alternate hypothesis?
The null is that the number of words reported correctly is on the both left and right ear are the same.
Okay, so it's same number of words from both ear and alternate.
Alternate, I say that the words reported correctly on the right ear is more than the left ear.
Right ear is more, yeah, correct. Because it's a you want to see whether because here whether right ear more accurate than left ear. Okay, so it's right ear more accurate than um, rather more accurate than left ear. Okay. So in this case, after you perform your test, what is the test statistic? Okay, so because of this, right, the Wilcoxon science rank test, there's the two of the values. Okay, so this will be mean. We're talking about mean of the difference equals to 0. And then this is the mean of the difference is less than 0. Okay, so which statistic will you use?
Is it the absolute sum of the negative?
So is it W plus or W minus?
W minus?
No, you still use W plus.
Oh.
Yeah. So what is the W plus?
My W plus is 13.
Yeah, right. So you also use W plus 13. Then given the critical value is 3. So what will the conclusion?
Fail to reject null hypothesis.
Hello. Fail to reject null hypothesis. Okay, so that means the 2 years are the same. So this is actually the question that I have already. You already answered. This will be your dependency test. Okay, also known as your PET test. Okay. So why do you use W plus instead of W minus? You have to go to your lecture. Where on earth is it? Okay, because it is less than your null hypothesis, alternate hypothesis, because it's less than. That's why I use W plus. Okay, which is why I kind of wrote it out for you here. So Jenny, you understand why?
But how you know that the MD is less than 0?
Okay, because you take your left minus right, ma. So if left minus right, that means the number of words on right. If it's more, then it should be more than less than 0, right? Because it's smaller number minus a larger number.
Oh.
Yeah.
Oh.
So it depends on which one minus which one, ma. So you have to be careful with it.
Okay.
All right. Okay, so we go to a true false question and we are done. Okay. Yep, the last In fact, today is the last tutorial. Okay, so 1A, for all the hypothesis tests regarding ordinal data, we have to assume that the underlying population follows normal distribution. Is that correct? True or false? Jian?
False.
False. Yeah, we cannot assume. That's why we have to do a test. Okay. The alternate B, the alternate hypothesis for Wilcoxon rank sum test is that the two variables are not correlated. Is that true? Hui Ping?
False.
False. Okay, nothing about correlation. Okay. In fact, this correlation you talk about your chi-square test. Okay. To perform Wilcoxon rank sum test, you have to rank each group separately rather than together. Is true or false? Jeremiah? Jeremiah?
True.
Separately,
Eh? Oh yeah, false, sorry.
okay. You don't rank them separately, rank them together. Okay. So this is what happened, what rank sum test? Is it rank? So what? Which is the question? Rank sum test, yeah. So rank sum test, you go to a lecture. Yeah, you rank them together. Rank them together first. First you rank them together. Okay. All right. So for Mann-Whitney test and Wilcoxon rank sum test are different tests. Okay. The Mann-Whitney test is used for dependent samples or independent samples, while the Wilcoxon rank sum test is used for independent samples. Is that true? Rajini?
False.
False. Yep. Correct. Okay. If the sample size is large, we can approximate Wilcoxon rank sum test using a Z distribution. Sean?
True, sir.
True, correct. Yes, we can estimate that. Okay. Last few questions. We can only conduct a two-tail test for Wilcoxon signed ranks test. Michael? That means only two-tail test, no one-tail test.
True.
Is it true? That means can you do a two-tail test? No, it's false. You can actually do a one-tail test as well. Science rank test. So science rank test, right? Yeah, our question 5. This is a one-tail test. Yeah, so we can actually do a one-tail test. Okay, so this is false. Okay, we don't bother our fragment test. Let's go to H. Okay, H says that for Wilcox, okay, stupid thing. Okay, H says that for Wilcoxon sign rank test, when ranking the magnitude of the differences, we ignore the data with difference of 0. Okay, is that true? Akil?
Yes, true.
True, okay, correct. Yeah. Okay. If the test statistic for Wilcoxon ranked sign rank test is greater than critical value, we reject the null hypothesis. Is that true? So, Zul? Test statistics greater than critical values. Sign rank test. So let's go to a sign rank test. Is it true? Zoo? Zoo, are you there? Or is Zoo responding on the meeting chat? No, no response as well. Okay, anyway, let's go to then Tracy.
False.
False, correct. Okay. Yep. Basically, is this. Okay. We reject only if the test statistic is smaller than the critical value, not the other way around. Okay. All right. So that's all for today. We have covered everything. Any questions?
Sir, may I ask concerning question 3B, sir, the one about the Wilcoxon rank sum test, sir, when we are trying to explain why we chose that test, it is because the data involves two groups with different individuals, and also because the army recruits sample does not follow a normal distribution, sir.
Okay, the only reason here is if the army recruits doesn't follow normal distribution. That's the only reason. Okay, if both are normally distributed, then you'll use a t-test. Okay,
Uh,
so that
yeah,
which also means that there will
yes.
be some people in working life, there will be some people that don't bother about t-test. They just use your Wilcoxon rank sum test. That means there are people, there's some um, certain people who actually use the non-parametric test only. They don't bother about the normality, because if you use non-parametric test for normally distributed data, it is still okay. But if you use the other way around, that means you use parametric test for not normally distributed data, then it's usually wrong. However, having said that, in statistics, the statistics tests have this thing called robustness. Robustness simply means that how bad the data must fail the assumption before it will break the test. Yeah. If you realize, right?
Yes, sir.
Yeah, okay, if you realize what happened is, yes, you have up to your two samples, your repeated measure, you still have fragment test, which means that you can use, there is a non-parametric version for two-way ANOVA. But for three-way, four-way, there's actually no non-parametric version. You still have to use ANOVA anyway. Okay, so there's a limit to non-parametric tests. Non-parametric tests, there's actually no limit. All right? Yep. Any other questions? Okay. If not, then that's all for today. Yep. Sean.
Sir, also concerning question 5B, sir. 5B about the dichotic listening, sir. Sir, is it acceptable to write the null hypothesis as there is no difference in how accurately adults above 60 years old report verbally presented materials from their right and left ears?
Yeah, it's correct.
And for the alternative hypothesis, could we?
Okay, so what's the alternate hypothesis? John, what's the alternate hypothesis?
Oh, so the alternative hypothesis is there is a difference in how accurately adults above 60 verbally presented materials from their right and left ears, sir.
Yeah, yes, for now hypothesis is correct. Okay, But for Sean, what happened to you is you have to learn how to shorten the number of words that you use. Okay, a lot of information need not be placed there. Okay, otherwise your report will always go too wordy. Okay, so learn how to reduce the number of words you use, but the meaning is correct. All right.
Yes, sir.
Okay.
So those are all the questions I have so far, sir.
Okay.
Thank you, sir.
All right. Any question from the rest? Koichi, any question? Ben? Ding? Nobody? All right. Then that's all for today. It's a fast one. And yeah, that's all. And we'll see you next semester or something like that. Hopefully all of you pass your exams. Or there's no exams, pass your module. Good luck. Have fun. Bye-bye.
Thank you, sir.